Welcome to The Explainer. Today, we're going on a bit of a hero's journey. It's a story about risk, failure, and, well, heroism, all happening inside the world of modern software. We're talking about how today's applications manage to keep their promises in the face of absolute chaos. The hero of our story? It's called the Saga pattern.
You know that feeling. You find something you want online, you click place order, and that's it. So simple, right? Well, on the surface, maybe. But behind the scenes, that one little click just kicked off a really dangerous journey through a whole network of separate systems. And if any one part of that journey fails, the whole thing could fall apart, leaving your data in a total mess.
So, to really appreciate what our hero is up against, we first have to understand the world it lives in. We're talking about the world of microservices. And this is where the whole challenge of keeping data consistent across different systems really begins.
See, back in the old days, things were a lot simpler. You had what's called a monolith, one giant application connected to one single massive database. If you wanted to place an order, the system could just wrap the whole operation, taking the payment, updating inventory, creating a shipping label in one single database transaction. It was all or nothing. It either worked or it failed and rolled back like it never happened. Super consistent. But today, we live in the world of microservices. Every little piece of the application is its own independent service with its own little database. And while that's amazing for building big, scalable apps, it creates a huge problem for keeping things consistent.
And this is the critical question, isn't it? You can't just stretch a traditional transaction across an order service, a payment service, and a shipping service, each with its own database. It just doesn't work that way. So what happens if the payment goes through but then the shipping service fails? How do you stop yourself from charging a customer for something that's never, ever going to arrive? This is the distributed dilemma. And this is where our hero finally enters the story, the Saga pattern. It's a design pattern that was specifically created to manage these long, complicated processes that span multiple services. It's all about making sure data stays consistent without having to rely on those old-school transactions that just don't scale.
So, what is a Saga, really? Well, it's not one giant all-or-nothing operation. Think of it more like a chain reaction. It's a sequence of small, individual, local transactions. Each service in the chain does its one job, commits that change to its own database, and then basically passes the baton to the next service in line.
Now here's the Saga's real superpower, the compensating transaction. The core idea is that for every single action you take in the chain, you have to define another action that can undo it. So if you charge a credit card, the compensating transaction is to issue a refund. If you reserve an item in inventory, the compensation is to release it. This is the secret to cleaning up the mess when things go wrong.
All right, let's walk through the happy path, where everything just works perfectly. A customer places an order. The order service creates it and basically shouts, hey, an order was just created. The payment service hears that, processes the payment, and then shouts, okay, payment processed. Finally, the shipping service hears that, prepares the package, and done. The Saga is a success. Every step was its own local transaction, and the whole thing just flowed beautifully. But what happens when things go wrong? Let's say the order gets created, the payment goes through, but then the shipping service fails. Maybe the item just went out of stock. The shipping service has to report a failure. This is where the Saga kicks into reverse. It triggers the compensating transaction for the payment, which is a refund. Then it triggers the compensating transaction for the order, which is to cancel it. The system is back to a consistent state. It failed, sure, but at least no one got charged for an item they're not getting.
Okay, so now we know what a Saga does, but let's dig into how it's actually implemented. It turns out our hero can have two very distinct styles, almost like two different personalities. One is called choreography, and the other is orchestration.
With choreography, it's all decentralized. Services just listen for events from each other and react. The order service publishes an order-created event, and the payment service, which knows it's supposed to listen for that, just springs into action on its own. It's like a well-rehearsed dance. Orchestration, on the other hand, is totally different. There's a central controller, the orchestrator, that acts like a symphony conductor. It explicitly tells each service what to do and when. It sends a command to the payment service, waits for a response, then sends the next command to the shipping service.
So which one do you choose? Well, they both have the trade-offs. Choreography is fantastic for simple workflows, with just 2, 3, maybe 4 services. It's very loosely coupled, and there's no single point of failure. But man, as you add more and more steps, it can get really confusing to figure out what's actually happening.
Orchestration is usually better for those really complex, long-running business processes. All the logic is in one place, which makes it way easier to understand and debug. The downside? That orchestrator itself can become a single point of failure.
But here's the thing. Our hero isn't perfect. Every powerful tool has a trade-off, and the Saga's is a big one. It's a critical flaw that you absolutely have to understand before you use this pattern, and it's called the isolation problem. Okay, remember how we said each step in a Saga is a local transaction that commits right away? Well, that means its changes are visible to the entire rest of the system before the whole Saga is even finished. Sagas essentially sacrifice the I in ACID, that's isolation. And this lack of isolation can lead to some really weird and tricky situations. Let me give you a concrete example. Imagine a concert ticket system. Saga number 1 starts processing a refund for a customer, and it releases 50 seats. The system immediately adds those 50 seats back to the inventory, and everyone can see them. Now, before that first Saga can finish processing the refund, a second Saga kicks off for another customer who sees all those available seats and books 80 of them. And then, Saga number 1 fails. Maybe the credit card company rejected the refund. Now it has to run its compensating transaction. The Saga needs to take back the 50 seats it released to get the system back to its original state. But it can't. There are only 30 seats left. Compensation is now literally impossible. The system is stuck in an inconsistent state, and it's all because that lack of isolation allowed a second transaction to jump in and interfere with a process that wasn't even finished yet. This is the real danger of using Sagas if you're not careful.
So, are we just stuck? How do you fix this? Well, one common way is to add more sophisticated business logic. So instead of immediately making those 50 seats available to everyone, the service could put them into a temporary escrow state. They're held in limbo, just waiting for the Saga to complete successfully. Only when Saga 1 is fully finished and successful does the system move those seats from escrow into the main inventory. This works, but you can see how it adds a whole new layer of complexity you have to manage.
All right, so after this whole journey, the dilemma, the hero, the different styles, and even the hero's tragic flaw, what's the big takeaway? What should you remember when you're designing your own systems?
At the end of the day, the Saga pattern is a super powerful tool for keeping things eventually consistent in a microservices world. It uses that chain of local transactions and those all-important compensating actions to handle failures gracefully. You've got your choice between the decentralized dance of choreography or the centralized control of orchestration. But, and this is the big one, you must always remember the trade-off. You're giving up that strict transactional isolation, and that means you have to be smart and design your system to handle the weird anomalies that can pop up because of it.
And that really brings us to the final crucial question you have to ask yourself. The Saga pattern isn't just something you use by default. It's a very deliberate choice. It's a trade-off. You are trading perfect, immediate consistency for resilience and scalability. So when you build your next system, you have to decide what your business really needs more. For an e-commerce site, maybe resilience is key. It's better to process most orders successfully, even if a few need to be fixed manually later. But for a core banking system, you probably need perfect consistency. No amount of scalability is worth a single penny going missing. So which is it for you? Perfect consistency or resilience? The answer will tell you if the Saga's journey is the right one for your application to take.